Good. We've got a pretty good crowd for a Good Friday. Thank you all for attending. So I think without further ado, I will turn the floor over to Satra after saying that Satra does not need too much introduction to the usual ReproNim crowd. Just in case you don't know Satra, be aware that he is a senior research scientist and director of the Open Data and Neuroscience Initiative at MIT and the McGovern Institute for Brain Research at MIT. Today, he'll be talking about Undata, an AI-assisted unraveling of challenges around data models and schema. So, without further ado, Satra, the floor is yours.
Thank you, Dave, and thank you for having me here. Let me share my screen, put you folks on display so that I can see faces. And I will say, interrupt me away if the question comes up or other things. Uh, I will also say that as part of what I'm showing, I decided to rerun a bunch of things yesterday night. So maybe I will not be able to show certain things by the time this gets done, but who knows? Things are working away behind the scenes as I talk. Uh, I'm hoping to tell you a little bit about my excursions over maybe about 3 weeks. But before I do, I want to kind of start off with why these excursions. But the starting can't happen without saying a thank you to a lot of people whose thoughts and contributions over perhaps 2 decades have influenced these excursions in the last 3 weeks. And in particular, I want to kind of point out both the ReproNim team, but also something that's not listed here, which is the INCF Data Sharing Task Force, where many of these conversations started almost 16 or so years ago at this point. Um, I'm thankful to a bunch of things that have continued or helped me continue some of these conversations, sometimes only in my head, over the last 5 years or so. And many of the things I'm going to talk to you about is because of a lot of things we are doing. So, what do we do? Our group kind of focuses on understanding neurophysiology of human communication and its translational applications. We develop AI ML models for personalized medicine, specifically psychiatry or mental health or brain health related areas. And then, in the context of ReproNim and other brain initiative projects, we do a bunch of neuroinformatics and open science for preserving information and generating shared knowledge from cells to behavior. This goal towards mental health or brain health is can kind of be summarized in this figure a little bit. What we are hoping to do is to be able to assemble information from many different observable and introspective measures and interventions that people have through the lens of perhaps an AI assistant. This figure was created back in 2017 when AI wasn't as much of a buzzword as it is today. Uh, but all of those fundamentals of signal processing, feature extraction, feature engineering, adaptive learning, natural language understanding all existed and continue to do so as we think about how to bring many of the information in these sensor spaces together. And each sensor, mind you, has a lot of nuances. They're noisy, they're sparse at times, and we have to coordinate and control them. The third part of this figure is the connection to patients and caregivers and researchers themselves. That we need a system or an ecosystem that connects all of these pieces together in an efficient way. And this has led to kind of thinking about the complexity of human neuroscience. There's not only just the neurobiology, we have to understand that neurobiology in context, we have to understand it across lifespan, we have to look at it from the labels of disorders that we give it, and we think about the analytics that connects the data and the processes around the space. Uh, and this is just human neuroscience. We learn a lot of fundamentals of human neuroscience through the study of neuroscience in other species. So there's some other dimensions that also connect to this complex space of thinking. So towards this, part of this is motivated by a vision for an AI-enabled neuroscience system to connect the dots across the complexity of spaces. One of the central challenge that we feel today has emerged is not that we don't need more data. We need more data. We need to continue to generate it, but we also need a coordinated integration of information across brain, cells, circuits, behavior, and clinical context. And there are many large initiatives currently underway to help with this promise of multimodal brain mapping, connecting with reproducible computation and AI-ready data resources. And I might say, we have some thoughts on what AI readiness means, and perhaps this talk today is a little bit of a prelude towards what true AI readiness might require. This AI-enabled infrastructure, I claim, has to be modular, self-describing, and programmatically accessible ecosystem where humans and AI collaborate to capture, curate, and refine scientific knowledge. And we need to start treating intelligent infrastructure as a core scientific instrument, as we have done with many other tools over the years. And this was essential to accelerate discovery and improve clinical relevance because it will connect the information spaces that many of us live in and spend perhaps our lifetimes in some of these spaces. And this figure kind of summarizes a little bit of this contractual vision towards it, that many systems exist in this ecosystems. We hope that each of these systems modules meet fair, care, and trust principles. They could be an AI system, they could be a knowledge base, they could be a data repository, they could be a standard high performance computing place. We hope that in this ecosystem, human and AI participants agree to recommendations and create provenance-based attribution of not just where humans interact, of every possible thing in the space that interacts with each other. We think that this will require human and AI coordination and evaluation. And perhaps most importantly, I think of this as a contract between these pieces, these jigsaw puzzle pieces that make up this space. This contract needs services to be self-describing, can be validated externally, has provenance and audit, has schematized I/O, and is versioned. Things that we've been talking about in ReproNim for a long, long time. And within this space, one of the elements that have come up kind of took me back a few years. So, over the last couple of decades, we've been involved in many different components of what we have come to recognize as the neuroscience ecosystem. This started when I was in grad school with creating batch processing and pipelines for SPM2 at a time when batch processing did not exist. And then went on to NiPipe, MindBoggle, IPython, scikit-learn, NiDM, NWB version 1, BIDS, HudiConf, Pydra, Dandy, NoBrainer, ReproSchema, ReproLake, NeuroBagel, BrainKB. So we've kind of covered a lot of spaces in this neuroinformatics space. And I wanted to bring up a figure that we had put into a grant application in 2013 that was kind of a precursor to our even the first phase of ReproNim, which said, at present, we have limited, often ad hoc standards, limited unstructured data sharing, limited transparency, limited validation and reevaluation, and limited machine readability. And the future we hoped back in 2013 that we would get after 5 years would be open data standards, transparent attribution, automatic value, impact metrics, trust through provenance, and significant vocabulary coverage. Well, I'm happy to say that even though we did not get the grant, this particular grant, there are many other resources and awards over the years that have helped kind of make that transition to that future that we envisioned back then. And vocabulary management was one of the essential elements of that proposal, and I would argue remains today. But it's not just concepts and terms, it's also data elements. And that's where we come into what I'm going to talk about a little bit today. But before I do, I will say that what I'm going to talk from the next slide onwards has been somewhat of a partnership uh, between various agentic systems and myself over the last few weeks. And I went into it with the notion of what can I do with this? And I have Yarrick to thank for who's on this call. And back in January, he said, Satra, you should look at SpecKit. I was like, okay. It was on my books, on my to-do list somewhere. And at some point in time, early March, it's like, okay, time to take this on. It was also related to this world of problem solving that has come about. And I give an example of something from Donald Knuth, somebody who wrote The Art of Computer Programming. And he was working on some problem, writing the future version of Art of Computer Programming. That Claude, Opus 4.6 specifically, was able to solve one of the problems he had been considering an open problem. Uh, Now, what I don't show here in this particular slide is that this wasn't just him and Claude solving it. This was him and Claude and a friend of his and a colleague of a friend of that and Claude and the friends all working with different experimental cycles to bring to bear the solution to this problem. And I think that's something we should keep in mind as I show you what I have done. This I have done so far by myself, working with Claude, but I hope this becomes this human endeavor of us doing some of these things together. Towards that note, I'm going to help describe, and everything from here on out is a contribution of Claude and me. Uh, Undata, a universal data element registry for neuroscience, building a shared resource for neuroscience data schemas. Now, many of us, many in this call, have tried to do this in various forms over the years. The three critical problems that have driven us over that period of time: schema fragmentation, same concept, are stored in many different formats. JSON schema, YAML, LinkML, Python classes, JSON LD. No way to easily ask, what does BIDS call the thing NWB calls electrode array? Does it even exist in BIDS? I mean, I might say today I know that it exists in some form. Is it the same thing? We also are looking at identity conflation. What something is not equivalent to where it came from. So age in BIDS and age in the Allen Institute for Neural Dynamics schemas are treated as different things despite being semantically and perhaps even structurally identical. And as we go across data sets generated by different kinds of things, we end up creating these invisible transforms, silent data transformations in ad hoc scripts, in consortia or other places that group this data together. And there is no provenance record breaking reproducibility. And these problems scale with every new dataset, standard, and ecosystem. So I took this as a challenge. This is a place we have lived in, and said, what can we do with the set of modern tools and technologies we have to solve these critical problems? Why this matters is we have a lot of inefficiency. So researchers waste weeks mapping between data sets manually. And while we have standards, the standards align certain parts of data sets, not all parts of data sets. Cross-ecosystem analysis is increasing. Some may say we don't need to do much of cross-ecosystem analysis because they live in different spaces and modalities. But if I go back to my figure of connecting the space of human neuroscience, a fundamental requirement is that you are able to connect pieces of information across these ecosystems and match them in some way or transform them some way. And this requires perhaps not so heroic, but sometimes it does require heroic bespoke engineering. The transformations, how we do these mappings from one to another, are often undocumented, results are not reproducible, and we still continue to have a fragmented landscape where new standards are being built with no machine readable crosswalks necessarily being built across standards. Again, this cost compounds with every dataset, every study, every collaboration. So we were hoping to address this through a few things. One is that any element represented in the system has to have some kind of content addressed identity. This is not about what value that element is associated with. This is about the element itself. We need to be able to say that a data element, which has a particular data type, a unit, pattern, constraints, maybe connected with some ontologies, has a hash associated with what that element is and means. And two elements describing the same concept and units and ranges should mash up automatically because of that hashing. The second thing is we want to decouple this identity from provenance. We want to know what an element is, not how it was measured. That's a separate question. So I'm going to set that aside as that has to be tracked as part of the system. We want to be able to say what it is. Now, some may argue that it's impossible to say what it is without tracking its provenance, and I'd be happy to have a discussion about that after I finish my talk. The third thing is explicit transforms. Every transform should be encoded somewhere, whether it's years to months, floats to strings, male, female to male, female. This should be addressed in some way in a system. So we hope that if you can do these three things, this will enable machine readable, reproducible data crosswalks across the neuroscience ecosystem. To achieve this, as I mentioned earlier, Yarek pointed me to SpecKit, and I went deep down into uh, the world that SpecKit put in front of me. So why is SpecKit useful? It structures an interaction with some of these agentic systems in a very structured manner. It has these 6 steps and more actually that come with it that allows you to kind of think about a life cycle for whatever project you are doing. Now, in this particular case, I'm building some infrastructure with some goals in mind, but this could be applied to many different things. As you might imagine, this could be applied to an analysis, that could be applied to a research question, this could be applied in ways that maybe it wasn't intended for when they brought it out. So it starts with specifying user stories and acceptance criteria. You kind of deliver to the agent what you want to do and what you want to achieve. And that starts creating a plan. And along the way, you can clarify different components of this plan. So this becomes a discussion. You can make it as detailed as you want. You can derive an architecture for the plan, in this particular case, as an infrastructure, a data model or contracts that come with it. And note that through the first 5 columns of this image, there's not a line of code being written. This is all design thinking. And this allows us to kind of work towards what we really want the system to implement without thinking about the code that will implement the system or the way you would carry out an analysis or something else. So after plan, it writes down a set of tasks that needs to be carried out to carry out the plan. And this includes dependencies, ordering, task breakdowns, what can be done in parallel, what needs other tasks to have been finished. And then the fifth stage, after all that is done, you can analyze all of this. And you can look at how consistent things are between the specification, between the plans, and between the tasks. And one of the things I learned over my exercise of using this, not just for this project, but across 5 different projects, uh, is you want to repeat clarification and analysis as much as possible to narrow down that you and the system are aligned on the set of things there are. The other nice things about SpecKit and using this in a software engineering or infrastructure building thing is that each of these specifications are written down and tracked, and any changes to it are written down and tracked. And when you do that, you have the entire history of your own thinking and decision making going alongside whatever you're building. The final thing is implement, and this will do a phase by phase execution of the plan and the task that it's carried out. And you can decide what these things end up looking like because you are defining what that specification is. So for this particular project, we've gone through about 40 iterations of specifications of this entire cycle over the different stages. Uh, it comes with a project constitution, and let me go next to that. A constitution defines core principles. And in this case, I said we need to be able to do environment isolation. So everything else, simplicity first, test-driven development, API first design, observability, no deprecation. Actually, let me take back. Uh, 5 and 6, no deprecation, environment isolation, and developer experience are 3 things I added to the constitution. The first 4 were things that were already there as part of the default constitution that exists. Now, I added a few other things, which I said continue to commit every single time because I want everything we are doing in the Git history that we do this. The no deprecation thing, I was developing this for the first time, and it was taking what one would consider good software engineering steps to say, if I wanted to change something, it would go into a deprecation cycle and leave something as backward compatibility around while I was making changes. So many things of systems thinking around software engineering were built into what SpecKit offers. I just added a few things that helped me along. So I said, no deprecation, I don't care if you override the whole thing and create a whole new API. Uh, we are building this for the first time. Nobody's using this at this point in time. Environment isolation. I wanted everything to be done either through UV VMs, bridging VMs between each other, or with Docker as container layers and bringing everything up for the developer experience. As you can see, it says version, ratified, and enforced on every PR. What this means is that this system took this constitution and will always follow it or will try to follow it at every step as you go along. And that versioning says the changes I made to adjust this constitution over time, and that itself is tracked in terms of what these principles are that will guide the system towards what it wants to do. Now, this could not have happened without standing on the shoulder of giants. And this is working with existing neuroscience standards, knowledge resources, and technologies. And you might notice even some recent things. I saw Carol in there. Homba, this was, yeah, the OWL file that Dave shared just last week. And we were able to pull some of these things in. But part of this is it allows us to integrate across a set of things that already exist in ways that we couldn't do at the rate of or at the speed at which we could do with some of the things I'm about to show you. So what does this implement? We implemented a three-layer architecture. There's a front end based on Next.js, a back end based on Fast API, and a library that was pure Python. The kind of details associated with these things. The front end uses Apollo as a client. That's a GraphQL client, a Tailwind as its CSS framework, and it implemented browse, search, curation, chat. There was an entity navigator, infinite scroll, all the kinds of things that you might get out of a front end. And for those people who know me, they know I'm not a front end designer or coder. This was all done by the system. This was me asking for what I wanted out of it, but the rest of it was coded completely by the system. The backend used Fast API with Strawberry GraphQL and Postgres with PG Vector for embeddings, binary JSON for flexible entity storage. I even connected through Keycloak or IDC authentication a connection to Globus so that I could use my MIT login to log into the system and do things with some identity provisions in there. And finally, there's a provenance-based audit trail for every mutation, which means a change in GraphQL language that's done through the system. The library itself was a place where we put in a lot of the logic. There are no database dependencies. There's standalone. There's pipeline logic for extracting things, and I'll go through some of these in a little bit detail in the next few slides. There's a storage backend protocol, and as with many good development things, it writes tests. This uses Python 3.14 and using UV for dependency management. The storage backend protocol has two kinds of backends, a file backend, which is a Parquet first, and parts of it use PyOxygraph, which is a toolkit for Sparkle type stores, and database backends, which uses Postgres and pgvector for other types of information. The pipeline itself is kind of the key to this. We needed to be able to extract information very quickly across different sources. And the sources we considered for this example were BIDS, NWB, Dandy, OpenMinds, AIND, OpenNeuro, ReproSchema, and NDA. Now, just as a very basic level, going across 8 sources would have taken us weeks, if not months, to do this ourselves. So just the first layer of being able to reach out, look at information in these spaces, and write source adapters that would translate information from that. And I instructed it to use LinkML as kind of a central point for capturing that information, and then to get to the various entities we were getting out of this. The second service is enriching these entities. We wanted to understand what they meant to each other. That was embedding similarity, being able to create embeddings for every entity, and adding LLM verification when things weren't very clear as an optional step to say what an entity should have been. The enrichment would also connect to what we're calling a little bit of a knowledge service. There are 11 ontologies with about 3 million terms, with about 322,000 of them embedded from a PyOxygraph RDF store that has pulled in all these ontologies. And I'll talk about what those are in a few slides from now. It will do cross-source alias detection, and that's an alignment it'll try and do, which is to say, hey, is a variable in one schema the same as a variable in another schema? And it's not trying to find exact matches. It does close matches, related matches, and other things, all defined through the lens of some of the ontologies and schemas we've been playing with. Finally, it'll commit some of these things with content addressing. Remember, I said we are hashing everything for each entity so that some element of consistency is made. It will deduplicate through that process and merge any fields as necessary. Finally, after doing that, it'll try to figure out how can I transform one entity to another? How can I go from age in years to age in months? And it will encode that as a new type of entity in the system. Coming back to the adapters, there were 8 source adapters. And this is where it was really interesting to see how the system approached each one of them. Now, I gave it some guidance along the way. Uh, BIDS, NWB, Dandy, OpenMinds, AIND, OpenNeuro, ReproSchema, and NDA all have information represented in different ways. So we needed a way of unifying them into this kind of entity format or model through a translator. And it implemented all of this together. So a base adapter was created, which extracted the information into a list of a classified entity. And those entities are either elements, schemas, value sets, or values. And each one was written in some cases where it would create an external environment, could be a Docker container, could be another VM, where it installed the dependencies because I didn't want it to pollute the dependencies of the current virtual environment in which it ran. And we were able to do this across the first 5, BIDS, NWB, Dandy, OpenMinds, and AIND. And then just in the last few days, we threw in OpenNeuro, ReproSchema, and NDA for good measure. So the speed and rate of change of being able to make some of these things connect to each other is amazing to see. For the content addressed entity model, as I mentioned, we have 4 different types of entities. There's element. So this is what we would say is a field level thing. Age, weight would be an element. A class level, something that is a structure like a subject, which may have multiple properties, may have inheritance. There's value, categorical, male, or value sets, modalities of imaging things. And it's able to kind of make this entity model come out of those adapters. It connects to transforms. And perhaps most importantly, there's a curation flag of quality that's associated with these entities. How well did it match what was expected of that entity? And finally, there's an audit log that tracks the provenance of a lot of these things. So all entities are staged and are expected to go through curator review once the system is running, and we wouldn't expect no changes, no automated changes without evidence. So how does content addressed identity work? We have kind of 2-mode hashing. One is ontology anchored. We have data type, unit, pattern, constraints, and primary ontology URI. That gives 1. If we don't have some of these things, it falls into what we call a structural fallback, which is data type, unit, pattern, constraints. But instead of the primary ontology URI, we're simply using the original class, attribute, and description as a way of hashing it. It's not perfect, but the structural fallback allows us to already match a lot of things because many people do use sort of somewhat similar names to do so. Uh, Provenance accumulation is what happens when we have many origins of the same entity. So we can see that the element age in this particular example has a source in BIDS, in NWB, in the Allen Institute for Neural Dynamics, and in the OpenNeuro DS228 dataset. And this allows us to kind of bring things together across many different origins. thus far, that cross-referencing is done automatically based on the alignment methods, which I think I might talk about. Um, so this multi-precision enrichment happens through many different things. We're using mini-LM to do embedding similarity across every single term. We're using some rule sets to do scoss mapping of whether something is an exact match or a close match or a broad match or a related match. We're verifying uh, through LLMs some of the representations as an adjudicator of how well certain things were brought in from the ontology space. And for certain things like species, for example, we now have 90 neuroscience relevant taxa. And by the way, yes, I did end up pointing it to pick up a few more species or taxa. Most of the initial formulation of the neuroscience relevant taxa were automated. It wasn't something that I had to specify as a list of things that it would do. It kind of figured out that these are common species that are studied in the neuroscience space. And then I augmented it with a set of species that it did not find that I know of that we are studying, whether in BBQS or elsewhere, that I could bring in. But that too was a pointer to a source, and I simply said, go and fetch all the species from that source. In the evidence chain, which I will talk about in a second, there is score, URI verification, and reasoning that all come in. And all of this is not perfect. Even if it says multi-precision, it will make mistakes, but it's a way to reduce the amount of mistakes that we see happening. So for the transform generation, we're using kind of three strategies. One, there's a shared ontology URI, elements with the same primary annotation, capabilities. We detect identity, unit type, conversion, value mapping, structural. In some early form of this, there were only 15 transforms that were detected to this. Then we extended it with name-based matching, group by provenance name, cross-source only, and that added up more transforms. And finally, we're planning to use, and this was just implemented, this is one of those changes I was making and hoping to bring this back up, semantic search, which is cosine similarity descriptions with some thresholds, which hopefully catches matches missed by name and ontology. It also does many-to-one mapping. So for example, in some cases, an age plus age unit might map to an element called age in years. And that's a kind of thing that now we have a system that allows us to treat this as a functional form of data elements, not just trying to match one to another, but being able to aggregate information across many sources, across many elements, and even write functions that map some of these across these spaces. So the entity navigator, and this is where I would have gone to the UI. I'll just quickly check. I don't think it's up yet. Uh, I will come back to it maybe at the end of the talk and hope that it's back up and running. Um, there's a core navigation, there's semantic linkages. You can link out to the ontologies and assignments that it has connected to. There's global search across these things with both lexical and semantic search. There's server-side sorting of these fairly large sets of rows that it's dealing with, and infinite scrolls, and pulling in information as needed from the server. There's source filtering. You can say, oh, I'm only interested in bids and narrow these down to various sources. And finally, annotation and provenance is provided for many of the elements. And as I said, I'm not a UI designer or a good UX person, perhaps. And it was able to capture all of these through some instructional form to make the navigation easier over iterations of this process. So hopefully this will provide an interface for seamless cross-repository navigation and verifiable semantic context. Now, what's important is that all of this runs through the backend with a GraphQL interface. So even if we completely skip the UI and said, you have programmatic access, you could create a layer which allows other systems to talk to this. And as we are moving into a space where more and more other systems are writing code for us, perhaps this will allow us to use the right variable name, create this alignment, reduce the need for crosswalk, in our systems because these entities will now be available for people to use as, or for systems to use as they write code that reflects some of these entities in their various projects. So from a detailed perspective, there's full semantic context. We have ontology and annotations with scarce relations, scores, expandable evidence chains, lineage and trust, where it came from, what was it named over there, and then the normal things that you might expect. How is it related to other pieces? Uh, then there's what we call a curation thing, which I will talk about in a few slides, is how do we figure out how to iterate on the quality of the data element over time. We are hoping that the metadata ensures semantic discoverability and provenance tracking, and this will continue to be a core component of the system as it moves forward. We have lexical search based on Postgres vector. We have semantic search based on mini-LM embeddings and a combined mode which returns immediate matches and adds on other results based on a semantic similarity. Now, here's where we were inspired by what was in CivicDB as a evidence-based curation workflow. So the evidence chain is something that's kind of heuristic or automatically determined, that there's a similarity score, some similarity methods is used for it, there's some target to some ontological reference if it exists, and something will verify that all of those things make sense. Then there are curation roles. There are contributors, curators, and admins who will help suggest annotations or flag issues. Curators will approve, reject proposals, resolve curation flags, and an audit trail tracks all of these things in terms of what these curations are. Now, a human did not generate 14,984 curation flags. This came through some of those initial evidence chain things around the curation. Now, it also turns out that it named every flag that wasn't curated with a flag. So a big chunk of this is simply because it attached this needs to be curated flag to every uh, entity in this space. Now, I put a little bit of a question mark to the no hallucinated confidence. I will say these are queryable by entity, user, and time. I can't guarantee that there is no hallucination fully. Maybe it's reduced because of the evidence chain and the principles that are used to construct it. As I mentioned, a lot of this was inspired by the CivicDB workflow of the community curation model, contributor, curator, admin, a revision-based workflow, concerns that entity type can be commented, flagged, or subscribed to, ensuring universal visibility and traceability, evidence and verification. We hope every change goes through curation and no automated change is applied without review, but we will see how that scales up as entities continue to grow, or the initial state when we have a lot of entities and it's harder to review them at the current initial point. This no hallucinated confidence comes from kind of, again, looking at every detail of what it means, why something was labeled as either a match or a related match, and understanding that there are many ways in which we can reduce the hallucination or the ability to just detect something as related. And I will say that the LLM enhanced reasoning chain part of this has increased in capability so much that it's many of the things I've seen, at least manually in introspecting it, have very little structure, very little chance for hallucination given some of the details. Now, this also depended quite a bit on whether it was just a variable name or whether there was a good description of that variable name and the context in which that variable was created. So it will still depend on us to make sure that our data sets are enriched as much as possible with reasonable metadata around the variable's names to decontextualize it and apply this kind of similarity matching to it. The LLM-powered curation assistant, I would say, is nowhere close to the ones we have already launched in services like Dandy and other places. And this is something that we need to kind of look at a little bit better. The underlying structure of this is built essentially off of what we have done with the Dandy. metadata editor. There's an interactive LLM chat. It connects to a set of tools. It can make smart suggestions. It can show you execution diffs and give you batch verification for candidate filtering when you're looking at some of these things. This, I would say, currently is the weakest part of this. And it's kind of strange given everything was done through an LLM-powered assistant to begin with in terms of developing this method. It's almost as if it cannot replicate itself very easily kind of mode right this minute. In terms of the knowledge service, we have pulled in a bunch of ontologies and data repositories that it can now access. But the intent of the knowledge service is for it to go out and scour different resources for various kinds of things. Um, to figure out what it might be able to pull. This doesn't mean it can be able to put some of this. Some of these resources don't have APIs or are not easy beyond web scraping to get at. But the intent here was either it's something that it can go looking for and then wait for curation, or we can provide and say, hey, go and fetch these things into the system. I'm going to skip this. I think we've talked about versioning all through ReproNim's existence, and this is not without versioning. Everything in this system, including the code, is versioned at every stage of commit. It allows data exports and downloads in standardized formats with detailed metadata, versioning, and you can do this through the user interface or through the infrastructure directly. From a developer experience standpoint, there's one command to everything. You just do Docker impose up. It has allowed for us to interact with it. I've been able to review things. The system has been able to build things. We have been able to quickly do certain parts of this pipeline. And the comprehensive testing is that it covers all lines of code. How good the testing is, given my situation that I wasn't looking at much of the code that was written, I can't speak to the quality of testing. But in many cases, because of SpecKit, even the quality of every function that I have looked at is usually better than what I have seen just out of randomly asking somebody to build a system like this. There is a standalone library without Docker, which allows you to do a bunch of the ingestion and other things. So it allows us quite a bit of flexibility from a developer standpoint to work with these tools. This was one of the interesting things about this. For those of you who have played with many of these systems here and that are on the call, I did not tell it to use any of these backends. The closest I came to was asking it to switch from REST to GraphQL between two versions of things. And I'll talk about what that versioning thing was. But everything else about how it would store data, how it would optimize different kinds of things was something it decided based on the statistical knowledge it had that associated those terms and information spaces with backend services that would best map to it. This is already old at this point. I was hoping to share a newer slide if things had fully run on the kinds of things that we have pulled in as a result of the updates. Uh, but it has pulled in a ton of different things around many different spaces. And this is with some guidance from me, but in general, a lot of the thinking space was done through systems that it already had access to. So my takeaways are generally a solid foundation and identity. I really loved the experience of working with SpecKit and being able to develop something that would allow me to work towards, given my thinking, given where I wanted, an interactive space of building something without writing a line of code. There was evidence-based curation, perhaps. It's, I would say, streamlined, again, allowing me to improve, tweak certain parts of this. Uh, Engineering, I would say, is quite rigorous. It does tests. It makes sure that everything is green before CIs are committed. Uh, the quick enrichment and transform is, to me, perhaps the weakest part of this. There's a lot of work to be done on the kinds of information that's available in the underlying sources and it did not seem to be able to get at every part of it without some additional guidance on things. So, for example, NDA already has a set of concepts around aliases of variable names and data elements, and it could not pick that up on its own when it downloaded the schema and looked at it. I had to nudge it towards it to make that work. The open and documented stack is out there. Every part of this is encoded. For those of you who are Git aficionados, I will say that originally when it started, it wasn't doing Git commits. So there's an initial stage of things that are out of the Git system, but the specs were written, updated. So the specs are all there. And that's where I had to make certain changes to the constitution to ask it to do commits and other things as it went along. All of this is available at GitHub, and you can contact me. This is powered by SpecKit Lifecycle, Light LLMs, Sentence Transformers, and DataLad. And for those of you who have been following news around the world, I was doing this with Light LLM right around the time when the Light LLM hack happened. For those who don't know what the Light LLM hack was, somebody released a version of Light LLM with a package that was put into it that basically slurped up your SSH directory and sent it to a remote server if you installed that version of the package, your environment variables and your SSH directory contents. It was tracked. Uh, just luckily for me, I was saved by two minor patch versions of that version that it had in cache that it did not go out to get that new version. But it figured out how to deal with DataLad. It figured out how to deal with Light LLM and talk to different LLM sources. It figured out how I could use it to connect to these different API services and the backends. Perhaps in all of this AI centricness, I'll leave us with the following sentence. Some of the people in our group have seen this, but I would love to remind us that in all of these things, I would still like to see a jumble of conversations, mistakes, cross-disciplinary misreadings, and serendipities. This is what I think brings all of us together in thinking about how we might advance a lot of our technologies and thought process and science and understanding in the space of these rapid changes of technology. So I'm going to stop sharing here. I'm happy to take any questions. And while I take questions, I'll check if I can show you and if the system is up and running.
Thank you so much, Satra. As with the last few presentations, man, I'm going to have to think for a long time about virtually every slide and the concept that fell in there because it was just uh, such a breadth of information. You said you were working on this is being driven by a couple of the real world types of things that you're working on, which I could sort of imagine what they might be. But can you say a little bit beyond this sort of general approach, the specific end user facing things that this may have been pointed at?
So I'll mention two things. One, I forgot to mention that, and Dave, I think you heard me say this when we met last week. I'll answer your question, but I'll just point out that this was the end product today was version 2 of a set of interactions with the system. Version 1 was where I stopped. That was about 28 specs into it and said, let's consider everything we've done till now as a brainstorm and let's start from scratch again with that process. And I just wanted to mention it out there because I forgot to mention it while I was giving the talk. Okay, coming back to your question as to where this could be used, let me start with two spaces that some of us know, ABCD and HBCD. And we've talked in both of these consortial studies of enriching the data elements and systems in terms of being able to find relevant questions, map relevant questions that a user may have to the variables that might correspond to this. That's one of those use cases. How do I find a variable? But now, if I knew a variable in some space that I'm associated with, maybe ABCD, is there a corresponding similar variable that was collected in HBCD? And I'll bring up some of the work in Neurobagel that has been done, right? Being able to say that this variable exists in this other data set remains this non-trivial problem right this minute. And I'm hoping that just being able to slurp up all these data elements, we will be able to at least curate a space of related variables across these sources. This goes back to, I think, a more fundamental question. Do we care about going across data sets and studies and other things? At least in the neuroimaging space, I would say we've already demonstrated the need to go across, I think, different data sets. Across the space of neuroscience, I think we are still a little far off, but maybe that's the space where such a system from an end user or an end developer perspective may already start for prospective alignment before things happen. And this is predicated on this notion that we might not write code anymore and something else will. And if that had access to a place where it found variable names it could use that match the intent, maybe we get alignment even before having to realign in the future.
Great. Other questions out there?
Hi, can I have a question?
Yes, please.
Sorry, I cannot. I think videos are not allowed, so you cannot see my face. But actually, thank you for the presentation. Very impressive. I have quite a lot of questions, but the first one would be the evaluation. So we talk about evaluation a lot in our group, and Struck Sense, we're also doing the evaluation, right? So based on my experience, I feel like when I try to evaluate LM results, I have to give them a lot of constraints to make sure everything is not hallucinated. So I feel like I'm following a very traditional way when I code questions myself, and I would apply the same logic to do the evaluation for element results. So I want to ask about your experience. I know you showed some the in the presentation you showed about how you do the evaluation or you how you make agents to do the evaluation. Can you talk a little bit more about that?
Sure. I will first point out that uh, in the infrastructure, LLMs currently play only two roles. One is during the enrichment process, if you turn it on, and the other is in that curation process, if you're asking it to do certain things for you. So I want to kind of decouple two pieces of this. Obviously, I used an LLM through this Claude agent to do all of this development, but the focus in this case was not the kind of system that, let's say, Tech and Pooja and Dorota are building with StructSense and BrainKB, where it's the agents themselves are the infrastructure
Mhm.
and they are doing things for you. In this particular case, all of the infrastructure is code, which means it's deterministic. Uh, and so, in terms of my evaluation of LLM, in that part is whether they're writing code. And this was why I wanted to push myself into the corner where I can't look at the code being written because of the rate and of scale at which it's writing code. How do I think about validation? How do I think about evaluation? And I was spot checking things, right? I can't even also look at the 300,000 elements or that it had extracted. And I think that's an open question still in terms of how do we think about what the accuracy of some of these things are. So where I could, I included heuristics to help improve uh, the accuracy of some of the things, but I know it's not fully accurate. And then the question is, what breaks down because of the inaccuracies? In terms of LLM judgment, and this is similar to what tech is doing in Struck Sense a little bit, at least the instances where the confidence of a match through the heuristic was low, and I spot check some of these things. And again, you'll hear me use the term spot check for now, and I'm trying to figure out a better way of doing this. Uh, I think of it as I found the answers quite reasonable and did a good job. But what I'm trying to get at is how can I improve that level of trust so that I don't have to spot check? Uh, and if the system is humanly curated, how easy is it for somebody else who spots something to plug that in? And that's where the curation part kind of comes in to be able to do so. Uh, I know this was not a good answer, eBay, to your question around how evaluation happens. I think that's still going to be a challenge in some of these spaces. I'm just trying to see if I can minimize through cross connections, uh, as low a risk as possible that something was wrong. And this is where, I mean, the number of data elements that exist on the planet is so high that if we trust certain sources, and that's why I started with the schema sources, right? Those are highly curated things. AIND went through manual curation. Open Minds went through manual curation. Those are kind of trusted sources. Um, Now, we might flag things even over there as saying, hey, this does not make sense. And that will bring up things to the schema originators, and those would be ideal places. So I would like to partition, I think, the space of evaluation. Things that have gone through curation, I trust a little bit more than things that have not gone through curation. So I trust Open Neuro's data sets the least in this space, uh, right? In the sense that many people may have done a good job. Many people may not have done a good job of curating those things. I trust the schemas a little bit more, and the schemas with ontologies a little bit more than those, because somebody in that space may have paid attention a little bit more than before.
My understanding is so you trust the input data. So how you trust the output based on how much you trust the input data, right?
Yes. And the output then becomes based on at least some of these things around semantic richness and semantic embeddings and proximity. They're not going to be perfect, but as far as I have seen, um, they're doing a pretty good job in connecting similar things close to each other. So again, this is not about perfect, this is about getting close and then
Mhm.
asking, can we iterate it? So if a human looks at it, the moment that happens, we want it to be kind of improved in a way that we don't have to go back to that.
Thank you. Oh, I have one
Great.
more question, but I can ask you later.
Okay, let's how about Cody?
Sure. My question actually factors in right off of that, which is, I guess, part one. Do you have a ranking of those trust values, and are you willing to expose that publicly to help create a feedback loop to drive increase in data quality?
So I was hoping that all of this would be live and public. Oh, by the way, all of this was done just between Claude Code and my computer. So it didn't even also require additional resources beyond what's available on a laptop in building and driving all of these things. So it's a very lightweight system from that perspective of what can be done with it. Um, so yes, I plan to put this up there, Cody, and hope that that will connect. I wanted a few more iterations of cleanup uh, before I put this fully in front of people, but anybody who's willing to help me out at that point in time. I will also say this was an exercise for me. I wasn't trying to create an infrastructure when I started this. I was trying to see if I could create an infrastructure, and what these systems allowed me and enabled me to do. So this was more about me learning about the process more than the outcome that it generated.
Terrific. Part two is just playing a little bit of devil's advocate here, but we often get this question in outreach to the broader scientific community. Um, your multi-step process of extraction and transform relied heavily on standardized inputs such as BIDS NWB, but it instinctually feels as if it could look at raw source data as it came off of the acquisition systems. Do you have any selling point in this process at which reliance on established schematic standards was either requirement, indisposable, was very useful, or not?
Uh, I think it was useful. Is it required? I'm going to kind of punt that, ask me in 6 months. Uh, and I say it's useful because there is a lot of human kind of curation and knowledge that has gone into the ontologies and other things that have been, the structures that have gone in there. I'm not saying whether they're good, bad, or accurate, inaccurate in terms of our current understanding of process, but a thought process has gone into many of those things. And similarly with schemas, a lot of thought process at whatever level has gone in to curate them. Uh, I hope that there's a future where what is acquired is almost prompted by such a system to say, you should be acquiring these kinds of things when you're collecting this data, maybe prioritize by the time it takes to acquire some of those things. Um, and then I will also reiterate that a lot of this was focused on data elements rather than raw data, uh, because I don't think we will see a world where, anytime soon, that it's all just raw data that we are operating on. Uh, and a lot of phenotypic and other data in the human space is continually going to be forms, questionnaires, and not just raw streams of behavioral or imaging or physiological data. Uh, Once we get to that stage, I think all of this is discarded and you just compute on that. Um, but I think that's still a while away. And in addition, I think if you think of parameters of instruments, I don't see how we would change not representing those things as data elements, at least in the near future. I don't think we have an instrument introspection system that captures some state of the instrument that could be modeled. So we will rely on parameters for a while, and this was really focusing on that as saying, can we bring the world of things together? And honestly, for me, part of this was in the past, we have shied away from doing that kind of aggregation just because of how time consuming it is and how useless it would have been because we would have needed human effort to do that alignment. This is exactly the space where the current set of technologies allows us to A, do the aggregation, B, some of that alignment, and C, get humans to maybe focus on things that seem important and should be cross-checked, and we can bring that in front of a pair of eyeballs.
Great. So fortunately, there's some job security for all of us, that there are still things that have to be done. We can't retire just yet. And this will be a conversation that continues for a very long time. And it's nice that it also crosses across ReproNim and BBQS and all these Dandy and all these other initiatives that are ongoing. I know we are past our official time. If Satra is available for more questions, and there are more questions, we can certainly do that. I wanted to at least get the record onto the record that our next month's webinar, May 1st, is the first Friday, will be by Jeff and the TRND1 team. So we're looking forward to that. Any other burning questions for Satra while we have him, or we all do know how to find him?
I have one question, if I can ask you. I want to know, have you ever so because you put everything out there, have you ever thought about how you can invite other agents to join the experiment, not just your agent, I mean, not just your cloud code, how about other cloud code?
Or other human agents?
No human agents.
Maybe it's both human and other. And I think this is part of the reason why I wanted to kind of do this exercise. It was hard for me to keep up with the rate of change. So uh, I I wanted a system, and that's why I love SpecKit, because it allowed me to go back and very quickly see what was done, or even ask somebody something to summarize the state of the last three iterations in some way. So between version 1 and version 2, I literally asked it, can you create a new vision doc based on all the things we have done in version 1? And because everything through SpecKit was so meticulously annotated, that it was able to follow the chains where it broke off what came back, what went away, and was able to kind of start into a space. So I've been doing a lot of these things in the way of asking the system to go and write a spec kit for existing repos of things. Now, Dandy was going to be my next thing over the summer, uh, which is, could we bootstrap the whole process? Because for some of the people here who have heard me say this, I want to see a completely dynamic infrastructural building system. And I think we are getting closer because of some of the tools and technologies that are there. So to your question, eBay, one of the things I'd like to do, at least in our group even, is figure out how our access to different agents can talk to each other.
Yes. Okay, you're gonna figure this out.
Yeah. I think
Okay.
there's some systems. I've thought of some pub sub kind of notions. And OpenClaw already implements some of these things in their system, which is the shared space. Now, I know I'm on record still. I will point out that the one downside to this that I learned was how quickly I could run out of tokens. Uh, multi-agent setups are beasts. They
Yeah,
are
that's
enabled
why.
in Cloud Code, and they wipe my token history, token resource out very, very quickly. I will also say that the instances in which I have used them, they have been very, very helpful and good.
Yeah, I would suggest you get a Chinese coding plan. They're cheaper.
I,
GLM.
yeah, we need to evaluate if there are other things that give us the same kind of performance. I don't know how to do that. I haven't had the time to play beyond a couple of these coding systems, and I don't feel like I want to go down the rabbit hole of trying to evaluate which one is better at each time. So I want to change how I'm evaluating it continuously as opposed to cross systems.
Okay. With that, we will all send our agents to next month's ReproNim webinar, and our agents will discuss what we learn and report back to us in the future. So thank you again, Satra. That was great. I'm looking forward to chatting further.